Hi, I'm DJ Ware. On this episode of the Cybergizmo, we're going to look at the world's most popular CPU. Right after this. I know, you read the title, so you already know. But what we're going to do today is we're going to explore ARM, and we're going to find out what it is. We're going to look at its architecture and how it differs from the x86. We're going to look and see how Linux supports ARM, or probably more correctly, how ARM supports Linux. We're going to look into the boot sequence, and then we're going to look at the trends, some of the performance that ARM has been gaining, both in sales and in speed. And then Intel has released yet another vulnerability for their Xeon-based platform. I don't know if this can get any worse for Intel. It just keeps coming. But let's look at a few facts. So back in 1981, the IBM PC was introduced. Yes, there were microcomputers before that, but it was part of the trend. The PC and the x86 architecture replaced the mainframes for the most part. Yeah, I know. There's still some around today, but they're not very common. It also supplanted the traditional large CPU supercomputers and turned them into massively parallel machines with many processors in them. Those processors today come from Intel, they come from AMD, they come from ARM. And it also replaced the terminal. It completely removed that and replaced it with the PC on the desktop. So here's what I'm wondering. Will ARM do the same thing that the IBM PC did? Because it's really a member of a different family. ARM is a member of the nanocomputers. So we've gone from mainframe, we transitioned over to mini computers. We transitioned from the mini computers to the microcomputers. And now are we on the threshold of transitioning to nanocomputers? Tell me what you think. I think we are. And the reason I think that is currently ARM is the most popular CPU sold. It's if we look at the number of cell phones or smartphones that were sold in 2018, that was 1.56 billion. That's 50 phones a second. That's just incredible. And 99% of those contained an ARM chip, or a chip specified by ARM. It could be Qualcomm, it could be a number of them. But 99% of those phones sold contained an ARM processor. Intel, in contrast, only sells about 300 to 400 million CPUs a year. So there's a huge gap between what Intel is selling and what ARM is selling. Plus, Intel is receiving pressure from AMD. This year alone, AMD sold 4 CPUs for every CPU that Intel sold in 2019. And that's only been since Ryzen 3. Now, I don't know what the transition was before that in Ryzen 2, whether it was 3 to 1 or 2 to 1. I don't know. I don't have the numbers for that. But I do know that currently it's 4 to 1. Linux developers are starting to move to ARM away from x86. I think there's a number of reasons for that. One is cost. Two is the servers on ARM processors are making inroads into the server business, and so developers want to be closer to those platforms. And the third reason, I think, is because they want to be free of the vulnerabilities. I know a number of agencies in the government, the US government, that are actively looking to replace Intel in their architecture space because they are concerned about the security vulnerabilities of the architecture, and I don't blame them. And so let's take a look and find out what is ARM. ARM is a UK company called the ARM Holdings Limited. ARM creates a specification called the ARM Architecture Reference Manual, reference manual. And in that manual, there's one published for each family of processors, and we'll talk about that. In there, they describe the instruction set, they describe the memory management unit, how interrupt and exception handling is performed, the caches, virtualization, and how those calls work. And there's a lot more stuff that's in that manual. And improvements in the ARM architecture come in families. Starting with the ARM 4, the 5, the 6, the 7, and 8. Those are progressively progressively better architectures as you move along. And so The ARM publishes the ARM, and the Architectural Reference Manual is what it is. And they publish one of those for each of the families. So ARM doesn't really create any chips. They just create intellectual property that they license to companies with chip fabrication facilities. Some examples of that would be like the ARM 926. That's an ARM version 5 variant of the ARM spec, or the Cortex A72. That's the latest in the core spec that supports ARM version 8. Now, the Dash A we'll talk about later. Right now, it's not important. So there's also, you can have multiple implementations because you might have big little. You might have some that have faster cores in them and then slower cores in order to take care, like in cell phones, what happens is in order to preserve the battery life, the process loads when the machines aren't very busy, they will transfer the load over to the slower cores in order to preserve battery life. So you could have a Cortex A5, a 7, 8, 9, 10, and 15 that go maybe from dual core to quad core to 6 core, and now even up to 8 core. And so they also might be, just managing different aspects of the machine based on what the manufacturer of the phone wants to have. ARM, of course, as we said, doesn't build or sell CPUs. So what is created from that specification is called the SoC, which is the system on a chip. And a SoC is almost a complete computer. It contains the CPU, the GPU, the Ethernet, the USB, the UART, and all of those things can be on the chip itself. That's very different from Intel. Intel has a few things on the chip, but not to the degree that ARM does. There are also security features on the ARM chip called like the trusted security modules. Those are on there as well. And all this is integrated onto the single chip. There's lots of SoCs that are available. There's some that are built and are specifically for automotive. There's some for the mobile, some that are low power applications, and some, of course, for the enterprise server market. Qualcomm's 8CX is the newest model that I'm aware of right now as the time I'm doing this. That is a 7-nanometer process, and it's an 8-core, and that belongs to the ARM version 8 family. So if you look at the block diagrams for a SoC, you'll find that on there is the components that are listed that are built into the chip itself. However, that may need some external components, like it might need RAM, of course, and it might need some storage, and that can be in the form of NAND or eMMC or an SD card. It could even have NVMe. That's becoming very popular to add to boards today, as well as you'll need some power circuitry to handle the power management on the board itself. Also, you'll need an external display panel, a keyboard, a mouse, and all that kind of stuff. And also, Wi-Fi and Bluetooth can either be external or it can be on the SoC. It just depends on the block diagram of that particular family. And also, there is some freedom within the vendor. They can decide how they want to implement that as well. Also, you might have an Ethernet connector and an Ethernet driver. You might have HDMI and other connectors like GPIO pins in order for makers to be able to add their things to the board. And recently, Arduinos have been added to the boards as well in order to provide that kind of capability. So once the vendor has designed the block diagram for the SoC, they then lay out all the components onto a board and solder all that together, and then they put it on the market for sale to us. So some examples, I'm sure you've seen this one before. The Raspberry Pi 1 was a SoC that was built by Broadcom 2835, and that belonged to the ARM version 6 family. Also, the current model, the Raspberry Pi version 4, is a BCM 2711. That is a Cortex A72. That's a quad-core chip, and that is a member of the ARM 8 version of the family, and that supports 64-bit. So one of the main differences in ARM versus x86 is that if I compile code for that Raspberry Pi 4, and I try to run it on a Raspberry Pi 2 or a 3 or a 1, it's a no-go. It won't run. Now, that's when I ran into installing Linux on Raspberry Pi 4, I noticed that it said ARM version 7. which I don't know what they're doing there. So it shouldn't work, but I'm not quite sure, and I never have quite figured that out. But if you know, leave me a comment below. I'd love to understand what is going on there, because it should be a version 8. So does Linux support ARM? That's the question, right? Does Linux support ARM? Well, it's really not the right, it doesn't give enough information in order to be able to tell you the answer, because there are 3 things you have to know. First, what's the ARM core? In other words, what family does that board that you're trying to put Linux on belong to? Is it an ARM version 8? Is it an ARM version 7? That's the first thing you need to know. Second, I need to know the SoC. Who makes the SoC? What model is it? Does it come from Qualcomm? Is it all winner? Is it a ROC chip? What is it? And then I need to know the board. Who manufactures the board? Is it a Raspberry Pi? Is it an Odroid? Is it a Pine 64? What's the board? I don't know. So you need to have all of those in order to be able to determine whether or not you can find a particular distro that's going to run reliably on that board. And in traditional x86, the hardware drivers are generally in the kernel. Now, you can have modules, right, for x86, but that doesn't work with ARM, and we'll explore why. But first, let's talk about the variants. So within, for example, the ARM 7 family, you'll find a -A. The -A stands for applications, and application means that this is a full variant of the chip, and it supports operating systems. Those operating systems can be Windows, it can be Linux, it can be iOS devices, it can be Android, or, and that's probably not going to be ARM 7, but Mac OS is coming. And that'll probably be either a version 8 or version 9, just don't know yet. I don't have any inside information, but some examples of the ARM version 7As are the Core A8 and the Core A15. ARM version 7M, M stands for microcontroller, and those are kind of reduced. Those don't, they're much smaller chips. They don't have an MMU, they don't have cache, they don't have support for the full instruction set. Now, on ARM chips, you have 2 instruction sets. One is the ARM instruction set, and one is Thumb 2. Thumb 2 is much smaller instruction set. And yes, Linux does support the -M. And some examples of the -M architecture is Core M3, M4, M7. I don't know which specific ones that Linux runs on. I have not run anything that requires a microcontroller in any of the things I'm working on. So there's also ARM version 7-R, which is real time. Those, I'm not aware of any Linux support for those. Those are usually in safety critical applications. They could be in devices, in medical devices. They could be in cars. They could be in manufacturing. In where you have hardware controlled items that are managed in the manufacturing process. And generally those are Cortex R52 is an example of that. They're always 32-bit though. And then there's the ARM version 8 that introduces Arch64. That's in a new instruction set. It supports both 64-bit instructions and addressing. The version 8, however, doesn't mandate 64-bit support, so you will run across chips that only support 32 bits, even in the Arch 8 family. They all support Arch 32, so that's a requirement. They have to be able to at least support Arch 32. Some examples of the 32-bit only are the Cortex A32, and then you have the new A72, which is a full-bore 64-bit CPU. And generally, you find the ARM version 8s in server markets, but they're also in like the Pine 64 Pro boards. They do support this particular chip as well. Lack of standardization. Yep, that's one of the big problems with ARM. So the first one we talked about briefly is that the instruction set between families is incompatible. Code written for version 8 doesn't run on version 7 and vice versa. So that's one problem that we've got. So for example, if Ubuntu says they support all ARM version 7s, but there's really more to that than meets the eye. First, that means that you can't run Raspberry Pi 1 and probably not Raspberry Pi 4. I noticed on their site, they specifically say Raspberry Pi 2 and 3. So it shouldn't run on Raspberry Pi 4. The other problem you have is that there might be device differences between those chips, those boards, excuse me, those boards. So That may be a problem for that distribution as well because the devices aren't defined for that specific machine. So the other thing is there's no standardization in the bootloader, and the ARM is memory mapped. Intel has assignments for interrupts. So a hardware device might be assigned to interrupt 13. So it's very easy for the ROM to discover devices because it knows that if I issue an interrupt, I'm going to get something back from the device. And when you're memory mapped, that doesn't work. So yeah, BIOS. We don't need no stinking BIOS. There isn't a BIOS on a ROM. There's on the ARM. There is a ROM, but it's specific to the manufacturer. And generally, it contains just enough code to load something out of non-volatile storage. And generally, what happens here is when and we'll get into this more when we talk about the boot example, but let's just talk about this for a moment in a high level. So when I apply power to the board, and I have all I have my SD card or eMMC device installed with Linux kernel on it. What happens is the ROM code will start up, and it will have just enough code to call something that's in either the SPI or some other location of non-volatile memory. That code is the code in the SPI that initializes RAM. So the ROM code can't start throwing things into RAM because it hasn't been initialized yet, and so you wouldn't get very far. And so that first boot level is to just get enough in order to find the U-boot and load it into RAM. Once U-boot is loaded into RAM, it assembles all the devices that it needs for that board, and it makes a call to the Linux kernel, and then it's gone. It's out of the way. So that's what happens. Also, there's no grub. There's no built-in mechanism to do things like booting into Windows and Linux on the same machine. Now, I say that there are ways to do it, and like the Raspberry Pi has done it. There's some other vendors that do it as well that allow for dual booting off of multiple devices, but there isn't an equivalent of grub, and there isn't an equivalent to be able to load an older version of the kernel or something like that, or to roll back, or to pass variables to the kernel as well. It doesn't use grub, doesn't use Lilo, doesn't use system deboot. U-boot is the method for most boards. There is BearBox that exists too, but to be honest, I haven't seen that in years. I don't know which implementations are still using that. I'm not aware of any. Raspberry Pi has their own custom version. They use a section of ROM code that's built into their GPU. And then that firmware then executes and supports loading from different devices. So that's kind of a custom thing that they wrote. But ARM servers are beginning to use grub, and what I'm hoping is they finish that and they get it back to the board manufacturers so that we can enjoy the benefits of at least having some way of controlling which kernel we boot without having to take the card out and reload it. Linux for ARM uses device tree tables. DTBs have been around a long time. If you go out to the Wikipedia, they credit Spark with that. I don't think that's right, because I remember seeing DTBs even as far back as the Motorola 6800 days. So Motorola was memory mapped, MIPS is memory mapped, Spark is memory mapped devices. We've had these CPUs around for forever, since early and mid 80s. I mean, we were booting machines long before Spark even existed. And we had to have device tree tables in order to manage the devices. So the DTB, basically, you have one of those for each device type that's on the system. You would have one, for example, for the HDMI. You would have one for the audio. You'd have one for the Ethernet, and so on. So if a distro supports a specific board, they have to have all the DTBs for that specific board in order for Linux to function correctly. Now, I have seen I worked with the Pine 64 Pro in the early days, and we didn't have all the devices working. And so the DTBs kind of came along and built up until they had all the devices working. So you don't need to have the DTBs all out there. It'll still work. It's just that if like an example, the HDMI driver wasn't around, well, we had to use the UART in order to be able to talk to the board. So, I mean, that happens. But when you get this in consumers' hands, you don't want that. So is the ARM install complicated then? It sounds like it's complicated. Actually, it's not at all. It's actually easier to install an ARM distro than it is an x86. Because a lot of it's done for you up front. The manufacturer supplies the DTBs. You already have the boot. All you basically do on an ARM install is copy the things into the boot directory, and you run a script in order to burn the firmware into the U-boot section of the system. That's it. And then you have the rest of your system on the root level of the device. So there are 6 Linux distributions with ARM support: Arch, Debian, Fedora, Red Hat, SUSE, and Ubuntu. I'm sure there are others. These are the ones I know about. If you know of some more, let me know. I'll be happy to hear from you. Some Arch trends. Arch chips are rapidly taking over Intel on mobile. Recent benchmarks by PC World, in fact, this last summer showed that the ARM chips were faster than even the Intel i5s, and that was on the version 8 level. I don't think the version 8 level. I don't think they've competed yet with the 9 series models of the Intel cores, and definitely they're not faster than the Core i7s. But you probably aren't buying ARM chips to do gaming on anyway. ARM will introduce 5 nanometer probably next year. Don't know for certain. I don't have any inside information. I'm just going by their roadmap that they published last year. And Intel is still just now rolling out 10 nanometer. So they're behind. AWS is offering ARM-based servers for virtualization workloads. And of course, they are pricing the ARM variants of those much cheaper than the Intel one. And so I think that's a good reason for people to move over to ARM. It's just going to cost a lot less to put them on that platform. ARM server processors are faster than the Intel Xeon E5s. There have been some, these are just integer benchmarks, but one of them took 9.8 seconds on an Intel E5, and another one took 8.9. But I will tell you that if you look at Phoronix, you'll see just the opposite. The ARM chips are trailing the Intel counterparts. But you need to pay attention to the X2 and some of the ones that are following on. ARM is definitely catching up, and they're catching up very fast. Plus the pricing, Intel's pricing, I think, went up over 150% last year. And that's hurting them. That is definitely hurting them. So, about the security vulnerability. So, researchers disclosed another vulnerability and allows SSH passwords to be leaked. And they're calling this NetCAT, and of course, NetCAT is one of the tools in pen tests. That's the CEB number, and what it does is direct data I/O technology and remote direct memory access allows data to be leaked out of those 2 elements. That affects all Xeon E5, E7, and SP processors going all the way back to 2012. This is a big one. Vergy University disclosed the vulnerability to Intel in June, I think the 23rd of this year, and then they discussed how they were going to release it to the public. And I assume that was to give them time to get a fix. And the fix that I've seen so far has been to disable direct data I/O. And that's going to slow down those processors a lot. At the very least, they're recommending to turn off remote direct memory access, and that may affect applications. AMD isn't affected by that vulnerability. There's a full report that's listed at the bottom here on that URL that you can go out and look at the full disclosure that they had for that vulnerability. I'm sure others will be talking about this as well. Not sure if ARM is affected or not. They weren't named in the report, didn't see their name anywhere. So with that, I think we'll just wrap this up and say a couple of things. First, we've learned that ARM isn't compatible within hardware families, within the ARM families. ARM supports 64-bit on the ARM version 8, but not all of those SoCs support it. ARM distros for Linux is dependent on 3 things: the SoC, the board, and the distro. ARM performance is catching up to Intel, and Intel had another vulnerability. So the question is, what's in your server room? Mine's ARM. It's behind me. And so I hope you enjoyed this today. And if you did, please like and subscribe, and hope to see you again real soon. And bye for now.